what am I squaring here? How do we call this a plus b? What is the name of a plus b? As I said, terminology, very important. I'm ready. So what is a plus b? What is the name of a plus b? Awesome. Two terms added. Yes, a binomial. Awesome. Thank you. So because these two quantities are added or subtracted, these two are terms. Yes. Every time we add or subtract quantities, those quantities are called terms. And you can say, what's a big deal with that? In my notebook, I'm going to write terms represent, if you want, quantities that are added and subtracted. This is a very important terminology. I have to remember what it means and use it accordingly. So what's the big deal? It's a big deal because there is also, we also have quantities that are multiplied. So when I multiply two quantities, how are they called? They can be terms because we know that terms represent quantities that are added or subtracted. But now I have to multiply. How are these two called? Thank you. So what's the big deal? Well, factors have more applications than terms. In many situations, if I want to solve an equation, I prefer factors, not terms. If I have to simplify rational expressions, I prefer factors, not terms. Can simplify terms. I can combine like terms, which I cannot do with factors, right? Depending on if they are like terms. But the applicability of factors is much wider than of terms. So I need to understand the difference, and I need to understand later on when we get to reviewing a lot of applications of factoring or factors. Awesome. So now I want to determine a plus b squared. That's my number one in the agreement. So what does this mean? And how many terms do I get? Yes. Awesome. 3 terms. Your colleague here? Yes. Thank you. So what terms?
A squared plus 2ab plus 2 squared.
Yes. Yes. Because I tortured many people before, so now they remember. So first term. This is what we call the first term. This is what we call the second term. Because you may not get A and B. You may get anything else but A and B. So now I'm adding 2 terms, and I want to square the quantity. And yes, a binomial squared is a trinomial. This is a trinomial, 3 terms. Every time I square a binomial, I will always get a trinomial. Good. So the pattern is this, and I would like you to make the effort to memorize this little tune. Okay? First term plus second term squared equals first term squared plus 2 multiplied by the first term multiplied by the second term. This is the first term, this is the second term, plus the second term squared. I'm not going to make you repeat after me, but I'm going to repeat it many times throughout the semester. And I want you to remember it. First term plus second term squared equals first term squared plus 2 times the first times the second plus the second term squared. If you move away from foiling this, I know it's very easy to FOIL. How do I know how to FOIL? Maybe some of you are behind, so let me go back for a second. What is a plus b squared? How did we get this? Here's how I got it. We have a plus b times a plus b. Do you agree with this? Do you agree that this is the same with this? And now let's say we FOIL. Let's say we don't remember how to get to this, right? So when I FOIL, I distribute a to both terms and then b to both terms. Are you with me? Okay, so we're proving this because I want to make sure that you understand where it's coming from. So a times a is a squared. How much is a times b? Perfect. Plus ba or ab is the same thing. And plus b squared. Would you agree so far? Do we remember this? Yes? Good. So obviously, these are two terms. That's how we get this. So we copy a squared. These two are combined because they are terms. I'm combining them to 2ab and then plus b squared. So finally, it's a squared plus 2ab plus b squared. Okay, so on your handout, you don't need to write anything on the form you give me, just your signature. But on your handout, I would write this. First term squared plus 2 times the first times the second plus the second term squared. And now let's work on an example. Here's my example. First term squared. This is my first term, and I want to square it. What do I get? How much? Awesome. Plus, I have 2 from the formula. I have to multiply 2x by 3y. First I multiply 2x by 3y. What do I get? 2x times 3y. 6xy. And now I have the 2 in front. 2 multiplied by 6xy. Very good. Plus, now I have the last term that I need to square. When I square 3y, what do I get? 9 y squared. Now, if you feel that you did not grasp this, let me know. Now, if you also, when you get home, say, I'm not really sure about that, make up another 5 examples. Make up anything else you want, like 3x squared plus 4y squared. And practice with that. And check using FOIL. But let's move away from FOILing because the problem is not with FOIL. Everyone can FOIL. The problem is going back and factoring. If I continue FOILing it, going back and factoring will be impossible. So I want to move away from that situation. Okay, can anyone give us the second one?
Squared plus 2ab.
Because it's minus.
Still plus, right? Because I thought it was minus b squared.
No, there's never minus on the last one. Minus 2ab plus b squared. Check it out with FOIL. The only difference is here in the middle. If this is positive, the middle term is positive. If this is negative, the middle term is negative. Because negative b times negative b will still be positive b squared. Very good. So can anyone give us an example? Let's do this one with minus. 3x squared minus 4y, everything squared. Remember the tune now. The first term squared. This squared. Remember when I square product of factors, I have to square both factors. 9x to the 9x to the 4th. Do we all agree it's okay? Do we all agree with this? Yes? I don't want anyone to fall behind. Are you with me? Yes. Good. Now, do I write plus or minus? Minus. Remember 2 from the formula times the first times the second. Multiply the first by the second. How much? 12x squared y. Awesome. 12x squared y times 2 in front. (24x squared y). Do we all understand this? Yes? Okay, plus the last term squared. The second term squared. Awesome. Very good. Okay, the last formula in our agreement is this. Let's FOIL it this time, but never again. So a plus b times a minus b. Let's FOIL. What will you write? A times a. Perfect. A times negative b. Very good. B times a. And then b times negative b. So this is the difference of squares. Not the sum of squares. That's not factorable. So this is a squared minus b squared. Okay, ready? Make one up for me. Anything you want.
X plus y.
4x minus 3y. I can't. The pattern is very clear. If one of them is 4x minus 3y, the other one must be 4x plus 3y. Otherwise, this doesn't work. I cannot apply this formula or special product. So this says the first term squared. What is it?
4x.
16x
Squared.
good minus
9y.
9y squared. Can we consider this done? And from now on, we know that a binomial squared is a trinomial. If it has plus, it's plus. If it has minus, it's minus. The only thing is that the middle term has a 2 in front. It's the product of these two, but times 2. Product of these two, but times 2. Here, if these two quantities are identical except the sign in between, they have opposite signs. Because if it's both positive, it's here. If it's both negative, it's here, right? So positive and negative is the difference of squares. Can we agree on this? Yes? Okay, awesome. Very good. So now I'm ready to start chapter 1. So with chapter 1, in chapter 1, we have 5 sections to look at. These are the 5 sections to look at. Equations and inequalities. A lot of this material should be reviewed, and you'll tell me. Let's go back to 1.1. And in 1.1, we're trying to graph. Okay, here it is. We're trying to plot points. We're trying to graph equations. And look at absolute value, quadratic, and cubic equations in a minute. We'll do that. and how to graph with it using a calculator, and so on and so forth. Ready? If you have your book, fine. If not, I do. It's on page 102. I'm going to start with a linear equation. So let's say problem 19 on page 102. And we have y equals negative 1/2 x. I'm asked to graph this, and first question I have for you is, what is it? I can't graph something unless I know what it is. Say it again. Yes, it is a straight line. This is a linear equation. Linear equation, indeed. How many points we need to graph a linear equation? Awesome. So it is highly recommended to get into the habit of determining x and y intercepts. X and y intercepts. For any function, if you ask me to graph any function, linear or not, I am going to look for the x and y intercepts. They are the most important points. Okay? Good. How do I get the x-intercept? Okay, so let's take a look at a graph. Let's say I have this graph. Does this graph cross the x-axis?
Yes.
Yes. Right here and right here. Does this graph cross the y-axis? Yes, right here. So these 2 points are called and this point is called awesome. Perfect. Now, can anyone give us the equation of this line? Awesome. Indeed, y equals 0. Y equals 0 is a horizontal line at 0, which is the x-axis. Good. So then, what do I know about these 2 points? They have something in common. Careful. Correct. That's the reason why they are found on the line y equals 0. Good. So the x-intercept then is determined when y is 0. Or are determined when y is 0, depending on the function. So I make in this equation y is 0. Are you with me, everyone? Okay, so then 0 equals negative 1/2 x. Negative 1/2 times what is 0?
0.
Correct. What is the ordered pair that we just determined? 0, 0. So it turns out that this particular linear function passes through the origin. Awesome. I have to make up another point because it happens that x and y intercepts are the same point. If I only have one point, I cannot graph an equation of a line. I need a second point. So let's make up another value for x. Let's look at this and come up with an x such that when I multiply it by negative 1/2, I get something easy to plot. 2 is good. Excellent. So when x is 2, 2 or 2 over 1 times negative 1 over 2, what do I get? Okay, so negative, oops, I didn't mean that. Negative 1 over 2 times 2 over 1, I simplify. What do I get? Negative 1 indeed. So when x is 2, y is negative 1. What is the ordered pair that we just determined in this at this stage? That's all I need. The first ordered pair I plot is 0, 0. The second ordered pair I plot is 2, comma, negative 1. I connect and extend the 2 points. I write the equation of the line somewhere so I know what I grabbed. Any questions on graphing a linear function? Any questions on graphing a linear function? Okay, let's take a look at an absolute value function, like 24. I should have not said that because I really wanted to ask you, what is it? But I spoke too soon. Okay, let's say I didn't say anything. So, what type of function is this? It's the absolute value function. Perfect. Okay, what do you think the domain of this function is? And we can go back for a second to this function. What is the domain of a linear function? The x values. The domain is the x values. So what can I plug in? What can I plug in a negative 1/2 x? That's a linear equation or linear function. So what can I plug in? Can I plug in 5? 0. Right? I just found x equals 0 when x equals 0, y is 0. Can I plug in 10? Negative 3. Negative 100. So what is the domain of a linear function? All real numbers. Domain, all real numbers. What about the range of a linear function? Good. Perfect. So now finally let's go back to our absolute value. So what do I do here? What is the domain of this function? The question is, can I plug in anything? So if you say to me, plug in 5, will I be able to give you a number back? Yeah, because the absolute value of 5 is minus 1 is? Good. If you say plug in negative 10, will I be able to give you a number back? If you say plug in 0, will I be able to give you a y value? So what is the domain of an absolute value function? Awesome. Good. So let's pick few values. Bless you. Let's pick few values of x. Negative 2, 0, let's say negative 1, 1, and 4. Okay. So please plug in negative 2 in absolute value is, and 2 minus 1. Perfect. Please plug in negative 1. Negative 1 in absolute value is 1 minus 1 is? Awesome. Please plug in 0. How much? Do we all agree with negative 1?
Yep.
Awesome. Please plug in 1.
0,
And finally plug in 4.
3.
Very good. Now from left to right, please give me the first ordered pair you would like me to plot. Awesome. Negative 2, 1. Next ordered pair that you would like me to plot. Next ordered pair. Next ordered pair. and 2, 3, 4, 3. Ready? What kind of shape is this? We know that the linear equation or linear function is a straight line. So this is y equals the absolute value of x minus 1. How would you call it? How would you explain to someone, hey, when you graph the absolute value, you're actually graphing a v. It can be this way, it can be this way, but it's definitely a v. Okay, so for example, just to illustrate this with a graphing calculator, in y equals, you will go to math and use numbers. One more time, let's do this again. So you will go to y equals, and you'll go to math, and then to the right to numbers. You will select number 1 by pressing enter. You will plug in x. These are all the variables, x right here. You will go to the right and subtract 1. Now, I would like to select a viewing window. And I select the viewing window. You can select the 6, zoom 6, which is the standard. And then you get the graph. Or you can select another viewing window. Since we already graphed the function, I know where the action is. I'm going to just say I only want to see between -4 and 4 with a scale of 1. And between -4 and 4 with a scale of 1. What does this mean? Between -4 and 4 with a scale of 1, a tick of 1 if you want, and between -4 and 4 with a tick of 1. Distance 1. And then I can click on graph. It's very clear what happens here. This is indeed the point you gave me. At some point in time you said -1, 0. At some point in time you said 0, -1. Then you again said 1, 0, and some other points. Now from the graph, I would like you to identify the range of this function. You already told me that the domain is everything. It's a friendly function, but I would like you to give me the range now. Between the smallest y value till the largest y value. Yes, -1, comma. Good. So what symbol do I put at -1?
Put a bracket.
Indeed. What symbol do I put at infinity? Always. Infinities are always parentheses. Any questions? Any questions? I'd like to move on to linear equations and rational equations. Okay. We'll come back after you do your homework and we'll do more problems. Any questions for me? Any questions? Oh, I can give you paper. You're welcome. Anyone needs paper to write on? Okay. Very good. So let's look at linear equations and rational equations. I'm on page 120 and 123. So I'm selecting a linear equation and then a rational one. If you have your book, you can select. Anyone would like to select anything you want? So 1 to 29, every other odd, but they don't have to be odd. You choose whatever you want, and then we'll look at the rest. Anyone wants to choose, or I will?
23.
Say it again?
23.
23. 23 is already rational, so let me choose a linear first. Let's say 14, and then we'll choose 23. So 14, on page 120, 5x minus 2x plus 2 in parentheses equals x plus parentheses 3x minus 5. Again, terminology. I need to understand, I need to know what this is. What is it? Careful. We're asked to solve. Maybe that confused you, I'm sorry. We're asked to solve. What is it? Yes, what type of equation? What type of equation? Okay. Does this, it's fine, don't say anything just yet. Is this kind of similar to this? Negative 1/2 x, 2x, 5x, x, 3x, 5, or negative 5. What can it be? Yes, it is a linear equation, right? So how do I know it's a linear equation? Because, first of all, there is no x in the denominator. If x is in the denominator, they cannot be linear. Secondly, the power must be absolutely 1. If it's 2, 3, it cannot be linear. And there are no products of variables. Good. What do I do here? Right. I have to eliminate. What am I eliminating? Correct. I have to eliminate this. Okay. Please dictate the left-hand side. Anyone?
Minus 2x.
So I have a negative 1 in here that needs to be distributed to these two terms. So negative 1 times 2x and negative 1 times 2, right? What about the other side? Yes? I have to copy x, right? Plus, good. What is my next step? Awesome. So the left-hand side is? The right-hand side is? Allow me to suggest. You don't have to switch to my method, but allow me to suggest. It's a linear equation. I have to separate the terms, right? The terms that have x from the terms that don't have x. I recommend the variable on your left. Sometimes I will use it. I will keep it on the right, but I recommend it on the left at all times if possible. So keep x on this side. Bring this term with x to the other side by simply changing its sign. And bring this term that has no x to the other side by simply changing its sign. Yes, I'm okay with you writing minus 4x plus 2. Don't. Let's move away from that. So when we move the term, any term from one side to the other, the only thing that changes is the sign in front. So 3x minus 4x is, careful, negative x. Negative 5, but plus 2. Good. So x equals 3. Again, don't change your method if this is not clear or you're not happy with it. But you will have to write way more steps than just this. Any questions? Any questions? Is this okay? Okay. So I like to look at a rational equation. I know I only have 7 minutes left. I talk too much, I know that. Problems 17 through 30 are not rational equations. Okay? That's my other book. They look rational, but they don't have x in the denominator, so they are linear. So allow me to choose a rational. And let's say 47. And we have 2 over x plus 1 minus 1 over x minus 1 equals 2x over x squared minus 1. This is a rational equation because it has x in the denominator. Okay. I know I only have 6 minutes left. I don't know if I can finish it in 6 minutes because I talk a lot. Okay. What is a potential problem when we deal with a fraction like this? Or like this? Or like this? What is a potential problem here? Remember again, it's all about domain. The domain of the function or the expression is always very important. So, what could be a potential problem with 2 over x plus 1?
Have 0
Where?
at the bottom.
Exactly. So 0 in the denominator. So division by 0 is, yes, impossible, but we like a fancy word. But you're right. That's what it is. Is
Defined.
undefined. It means it does not exist. So if I divide 5 by 2, I get 2.5. If I divide 0 by 3, I have $0 and I choose 3 of you to share my 0 with. But when it comes to 5 divided by 0, it does not exist. No number. Impossible. But we like this word. Instead of writing no number or impossible, we like to say undefined. So can anyone tell us which x value will make this undefined? The first one, the first fraction, undefined.
-1.
Correct. So then I have to make sure that that does not happen. How did we get that? For those of you who were not clear, I subtract 1 from both sides, or I move 1 to the other side, so I get x equals -1. Well, it cannot happen. Now let's look at this denominator. So what can you say about that denominator? What x value is not acceptable here?
1.
Exactly. Any questions? This was negative. The first one was negative, I'm sorry. I didn't write negative. Okay, I wrote it here, but not here, I'm sorry. So the second one is very clear, right? Do we all understand how we got this? We said x minus 1 equal to 0, we added 1, we got x1. Good. Okay, here's the method I recommend for solving rational equations. Here it is. I will move this fraction to the other side. What happens when I move a term or a fraction from one side to the other? What is the only thing that happens? Exactly, minus 2x over. Now, I would like someone to factor that for us. And we have an agreement. We have an agreement. And I want you to factor x squared minus 1. Which of these 3 special products will you use?
Third.
Of course, the third one. X squared minus 1. What will you write?
X plus 1 and x plus 1.
Awesome. That's why we need this agreement. You see how important this is? Now I took it from here. Good. So I know I only have 2 more minutes. So how would you already told me x plus 1, x minus 1. I have to write the equal symbol. And now what is left on that side?
0.
Awesome. Remember, if you omit the 0, you're not solving. You're changing the equation into an expression. Okay, perfect. Now, can anyone refresh our memory? Look what I did. I drew a long fraction line, equal symbol, and 0. Can anyone find the least common denominator for us?
X plus 1 times x minus 1.
Exactly, all different factors. X plus 1 times x minus 1. Any questions on finding the least common denominator? Okay, so then I'm going to write something that you should never do. I'm going to delete it, don't copy it. 2 minus 1 minus 2x. What is wrong with this? Why I cannot do this? Because this fraction had x plus 1, so its denominator was multiplied by x minus 1. If I multiply the denominator of a fraction by a quantity, what do I have to do to the numerator of the same fraction? By the same thing. So I make myself a note, hey, don't forget to multiply the top by the same thing you multiply the bottom. You multiply the bottom by x minus 1, you have to do the same thing to the top. Otherwise, you're changing the problem, you're changing the fraction, they're not the same. So now, can anyone give us what we multiply the top of the second fraction by?
X plus 1.
Right. And what do I multiply the top of the third fraction by? Nothing else. Wrong. This is horrible. Please don't ever do that. I'm not saying you would, but I just had to say it. Okay, I'm going to stop. I'm just going to write this and then we continue because I respect you and your time, so I'll stop. But I just want to write the top and we'll take it from here next time. Can anyone just give me the top?
X minus 1.
2 has to be distributed to these two terms.
So 2x minus 1.
2 has to be distributed to both terms. Okay, minus 1 gets distributed to both terms. Good. And minus 2x. We'll take it from here next time. Thank you so much.